Hello guys, welcome to the fourth lecture of the chapter Polynomial. Now, after learning the relationship between the zeros of the polynomial and their coefficients, now let's go ahead and try to solve the exercise 2.2 in which the same concepts are going to be used. So the first question says, find the zeros of the following polynomial and verify the relationship between the zeros and the coefficients. So, you know to find the zeros of the polynomial, right? By splitting the middle term. When it is so here all the polynomials given are quadratic polynomial. So to find their zeros, you are going to use the method splitting the middle term, and then you are going to find the zeros of the given polynomials. And then you have to just verify whether alpha plus beta equal to minus b by a and alpha into beta equal to c by a. Let's go ahead guys and solve the question. So the first question, we will solve it here. By splitting the middle term, I hope all of you know how to split the middle term. So I am not going to teach in this lecture. I hope you people know it. So let's go ahead guys. I am going to split this term. It's going to be equal to x minus 4 into x plus 2, x equal to plus 4 and minus 2. So these are the alpha and beta of this polynomial. If you verify this, alpha plus beta should be equal to minus b by a. That is 4 plus of minus 2, which is equal to 2, should be equal to minus b by a. That is minus 2 minus of minus 2 by 1, which is equal to 2, hence verified. Now we'll do alpha into beta, that is 4 into minus 2, which is equal to minus 8, which should be equal to c by a, which is coming equal in this case. So question 1 is solved guys. Now let's go to part 2. Here you will solve it as like this, and then you will take it 2s in common. This becomes, so in this case both the zeros are going to be equal, and 1 by 2 itself. So alpha plus beta is half plus half, which is equal to 1, which should be equal to minus b by a, which is equal, and alpha into beta So hello guys, welcome to the fourth lecture of the chapter Polynomial. After studying the relationship between zeros and the coefficient of the polynomial in the previous lectures, now we are going to go ahead and try to solve the exercise 2.2 of this chapter, which is going to be based upon the same topic which we learned in the last class, that is the zeros of the polynomial and the coefficients and their relationship. So now I have given, so this exercise, the first question is about finding the zeros and then verifying the relationship guys. So you have to just find the zeros like how you have learnt in your previous class, that is in your class 9th, by splitting the middle term of the given quadratic equation and then finding the zeros, and then you have to add them to get minus b by a, that is alpha plus beta should be equal to b minus b by a, and multiply them, that is alpha into beta should be equal to c by a, and hence you have to verify the given questions. That's the question guys. You can read the question once. Now let's go and see the first sub question guys. That is x square minus 2x minus 8. So now when you split the middle term, you have to split in such a way that the multiplication of these two terms gives the multiplication of a into c, that is 1 into 8, as you know, which you have learnt in your previous classes. So I am going to split it as plus 2x and minus 4x, which will when multiplied gives us the number 8, and the addition should give the same number which we have got in the previous step. So in this step we follow the splitting of middle term rule and then finding the zeros. In this question we found the zeros as 4 and minus 2. Now let's verify, guys. So alpha plus beta is minus 4 plus 2, which is equal to minus 2, should be equal to minus b by a, that is minus of minus 2 by 1, which is 2. So hence it is verified, guys. So alpha plus beta is verified. Now let's go for the relation alpha into beta, which should be equal to c by a. Let's see whether it's going to be equal to c by a. So 4 into minus 2 is going to give us minus 8, which is actually equal to c by a, which is minus 8 by 1. Now let's go to the second sub question, guys. Here it is, the variable of this polynomial is s. So 4s square minus 4s plus 1 is the question, guys. So again the same method we have to follow by splitting the middle term and then getting the zeros. In this equation we got the zeros, both are the same zeros, guys. We have got two zeros, but both the zeros are the same number, that is half and half, that is 1 by 2 and 1 by 2. Now if you add them, half plus half should give us minus b by a. Half plus half is 1, should give us minus of minus 4 by 4, which is minus of minus 4 is 4 by 4, 4 by 4 is again 1. So which is actually equal to sum of the zeros, guys, that is half plus half is also equal to 1 and minus b by a is also equal to 1, which means it is verified, guys. Alpha plus beta, we got it verified. Now let's see alpha into beta. Alpha into beta, 1 by 2 into 1 by 2 is going to give us 1 by 4. We should see whether it's going to be equal to c by a. So here c is equal to 1 and a is equal to 4, which means 1 by 4 is c by a. Also 1 half into half is 1 by 4, hence it is also verified, guys. Now let's go to the third part of the first question, that is 6x square minus 7x plus 3. Now if you follow the splitting of middle term and try to find the zeros, you'll get the two zeros as 3 by 2 and minus 1 by 3. Now if you add them, that is minus 3 by 2 plus of minus of 1 by 3, you will get the answer as 7 by 6, which should actually be equal to minus b by a. Here b is minus 7, so minus into minus 7 is going to give us 7. By a is 6, so it is going to be equal to 7 by 6, which is also equal to sum of the zeros. Now let's go ahead and try to find the alpha into beta, that is 3 by 2 into minus of 1 by 3, which gives us equal to minus half. If you see c by a, we get half, guys. I mean minus half by c, because c is minus 3 and a is 6, so minus 3 by 6 gives us minus half, which is also equal to the product of zeros, hence it's also verified. Now in this question, if you see what's unusual apart from all these questions is, here there's no c term, guys. It's only 4u square plus 8u, and in this question what's the variable of the polynomial? It is u. You are going to split the middle, you're not going to split the middle term, you're just going to take the common term. So you have taken 4u as common term, and then inside you'll get u, and here you will get plus 2, because when you multiply it you'll get this term back, guys. You can check it out. So here by finding zeros, 4u equal to 0 and u plus 2 is equal to 0. So values of zeros of that equation will get as 0 and minus 2. So alpha plus beta equal to 0 plus of minus 2, which is equal to minus 2, which should be equal to minus b by a, which should be equal to minus 8 by 4, which is actually happening in this case, guys. So it is true, and alpha into beta should be equal to 0, since any number multiplied by 0 is going to give us 0. So 0 should be equal to c by a. Here there is no c term, which means c value is 0. So 0 by any number is also going to give us 0. 0 multiplied by any number is also going to give us 0. So hence it's also verified, guys. Now we are going to see the fifth and sixth sub question of this first question, guys. The fifth question is t square minus 5. As in this type of equations, what you have to do is you have to just write it as t plus of root 15 and into t of minus root 15. The reason is a plus b into a minus b gives us a square minus b square, as you know from the formulas. In this case, so you'll get the zeros as minus root 15 and plus root 15. So alpha plus beta in this case will give us 0, because minus root 15 plus root 15 is 0, which is nothing but should be equal to minus b by a. In this equation there is no b term at all, guys. There is a term, there is a coefficient of a term, and then there is c term, and then there is no b term at all. So b is going to be 0, so 0 by 1 is going to also be equal to 0, which is also equal to alpha plus beta, which means the relation is verified. And the second relation is alpha into beta. So minus of root 15 into plus of root 15 is going to give us minus 15, which should be equal to minus c by a. Here c is minus 15 and a is 1. So c by a is going to be minus 15 by 1, which is also equal to alpha into beta. Hence even the second relation is verified, guys. You can note it down, guys. When you can note it down, you can catch the screenshot and then note it down. Now let's go to the sixth sub question. And in case if you didn't understand it, you can watch my videos again and again, guys, so that still you get understand. Now let's see the sixth sub question. Sixth sub question is 3x square minus x minus 4. This you can split it as 3x minus 4x, and then you'll, by splitting the middle term and factorization, by method of factorization, you're going to get the zeros as 4 by 3 comma minus 1 minus 1. These are the two zeros. So alpha plus beta is going to be 4 by 3 plus of minus 1, which is going to be equal to 1 by 3, which should be equal to minus b by a, minus of minus 1 by a, that is 1 by 3, which comes true in this case, guys. So alpha plus beta relationship is verified. Now let's go to the second relationship, alpha into beta, that is minus 4 by 3 into minus 1 is actually equal to minus 4 by 3, which is equal to c by a, minus 4 by 3. Hence also the second relation for the sixth sub question is also verified. Now let's, after seeing the first question, guys, you can practice more questions related to it. You can solve by yourself once you can solve the NCERT by yourself. Now let's go to the second question. So guys, after finishing the first question, now we are going to the second question of the exercise 2.2. In the first question, we saw how to find the zeros and verify the relationship with the coefficients with the given quadratic equation in the question. Now the second question is the opposite of it. In the second question, they have given us the zeros of the quadratic equation, which we have to find out. So the equation they have not given in the question, they have directly given the zeros, that is alpha and beta they have given. Now we have to find the equation. So this sounds a bit tricky, right, guys? The last question was so easy. They have given the equation where we found the zeros from the method which we learned in the 9th class, that is by factorization, and then we just verified it. But here it seems a bit tricky because it's the reverse process of what we did in the last question. So it's easy, guys. If you think, we know that there's a relationship between the coefficients and the zero. When they have given the zeros, we should be able to find the coefficients with the relation. So applying the relation and the zeros, we'll be able to track back the coefficients of the equation. Once you get the coefficients, just substitute it in the general form of the equation, then you'll be getting the equation, guys. Let's jump into the question and see how is it possible. So the first question, the zeros, they are given as 1 by 4 and minus 1. Now as we know, these are the two zeros, guys. If one is alpha, the other is going to be beta. Now using the relation, alpha plus beta is minus b by a. So 1 by 4 minus 1 is equal to minus 3 by 4, which should be equal to b by a, which means 3 should correspond to b and 4 should correspond to a, which means we have already got the two coefficient of the equation. If we just substitute it in the general form of a quadratic equation, that is in this place, we are going to get the equation. It's as simple as that, guys. The question might seem to be a tough, but it's actually not. For example, if you do alpha into beta, that is 1 by 4 into minus 1, you'll be getting minus 1 by 4, which should be equal to c by a. Right, guys? So, which means the value of c is going to be minus 1. You already got the value of the constant term, that is the value of c. At last, it's going to be minus 1. And you already got the value of b and a, that is b is equal to 3 and a is equal to 4. So just plug it into the general form, guys. The general form is ax square plus bx plus c. In the place of a, put the value of a which we got from this comparison. When you compare these two fractions, the numerator should be equal to the numerator, the denominator should be equal to the denominator, which means b should be equal to 3 and a should be equal to 4, which means it is ax square is 4x square plus minus of bx square plus b is 3, right? So plus 3x, and the value of c is value of c is 1, minus 1. So the equation which you are going to get is 4x square plus 3x minus 1. Similarly, we are going to solve for the second question. In the second sub question, In the second sub question, the zeros they are given as root of 2 and 1 by 3. If you do alpha plus beta should be equal to minus b by a, this is the relation first we are going to write. Now if you plug in the values, root 2 plus 1 by 3 gives us 3 root 2 plus 1 by 3, which should be equal to minus b by a. So which means this value is equal to minus b and this value is equal to a. We already got the value of a, guys. So ax square, which means it's going to be 3x square. We already got the value of a. So first term value we have already got it. Now to find the rest terms, let's do alpha into beta, which is going to be equal to c by a, which is root 2 into 1 by 3, which gives us root 2 by 3, which should be equal to c by a. So now we have to just plug in these values, guys. We have got this as value of minus b. So the value of b is going to be minus of this whole, because minus into minus is going to give us plus, right? Let me tell it once again. So this value is of minus b, correct? So this entire value is of minus b. Here in the general equation, we are going to plug in the value of plus b. We are just going to plug in the value of b. To get the value of plus b, you are going to multiply this whole term by minus, because when you multiply this whole term by minus, we have to also multiply this whole term by minus. That's when you will get minus into minus, you will get the value of plus b. That is the value of this whole into minus. That is, we are going to put a minus here, guys. Because of this reason, we are going to get a minus here. This is the whole value of b which we got. We are going to just plug this value of b into the general form of the quadratic equation, and then we have got already the value of a which is 3. So it is 3x square minus this whole value of b, and then plus c. The value of c is root of 2, which means plus root of 2. So the second part is over, guys. Now let's go ahead to the third part. The third part is 0, 1 by root 5 they have given. So alpha plus beta, that is 0 plus root 5 is going to be minus b by a. And alpha into beta, that is root 5 into 0 is going to be equal to 0, which should be equal to c by a. From this comparison, we are going to get the value of b as minus of root 5, because as I said you, since it is minus b, the value of b you are going to get by multiplying this whole equation with the minus, because minus into minus is going to give us plus, which means we'll get the value of b as minus 5. We are just going to plug it in the general equation. Then we have this term, the middle term we are going to get as minus root 5x. And the value of a, if there is nothing, so it's 1, right? If there is nothing down, you are going to consider this as by 1. So the value of a is 1. We are going to plug it in the general equation. We will be getting it as 1x square, which means it's just x square. So the term is x square minus root 5x. And here, since it is 0, which means alpha into beta is equal to 0, which means the term c is going to be 0. That is, the constant term is going to be 0. So that there is no constant term in the equation as well. Now let's go and see the fourth sub question, in which both the zeros are 1. That is, they have two zeros, but they are not distinct, they are the same zeros, that is 1, 1. Now if you apply the same relation, alpha plus beta should be equal to minus b by a, that is 1 plus 1, 2 should be equal to minus b by a, which means, again, as I said you, the value of b we are going to get by putting a minus sign. Minus of this whole term is going to give minus into minus b, which is going to give us the value of b, which is going to be equal to minus 2. So the thing is, we are going to plug this value of minus 2 of b in this general equation. We'll be getting the equation as minus 2x, the middle term. And the value of, as I said you in the previous question as well, since there is nothing down here, which means we are going to consider the value of a as 1, which means the value of a is going to be 1. So here in general equation, if you plug in the value of a as 1, we are going to get 1x square, which is nothing but equal to x square, minus 2x, and from here alpha into beta, 1 into 1 we are going to get as 1. And if we equate that to c by a, we are going to also get the value of c as equal to 1. When you put the value of c as 1, you are going to get this general equation, the final equation, guys. So after solving the 4 question, let's go to the 5th and 6th question of this second question. Now in the 5th question, they have given us the value of alpha and beta as minus 1 by 4 and plus 1 by 4. When you add alpha plus beta, you will be getting minus b by a. Same as the previous steps, what we have to do, you have to add these two values, minus 1 by 4 and plus 1 by 4 gives us 0, which means minus b by a is equal to 0, which means the b term doesn't exist in this equation, which means it's going to be in the form of ax square plus c, something like this. So the b term doesn't exist, p is equal to 0, the term x doesn't exist. So, and then you do alpha into beta, that is minus 1 by 4 into 1 by 4 should be equal to c by a, that is minus 1 by 16 should be equal to c by a, which means the value of a is going to be 16 while comparing this. Minus c, c by a is equal to 1 by 16 minus 1 by 16, which means the value of a is 16. So you're going to plug that value in the general equation in ax square. It becomes 16x square, and then the value of c is minus 1. So you're just going to put the value of minus 1 since there is no beta. The equation finally we should be getting is 16x square minus 1. Now let's look into the sixth sub question of the second question. And after that, the second question is going to get over, and also the exercise. The value of alpha and beta they are given as 4, 1. The value of alpha plus beta is going to give us minus b by a. 4 plus 1 is going to give us minus b by a, which means phi is equal to minus b by a, which means phi b is equal to minus phi. As I said, the value of b you will get by putting it, as I said in the previous step, you have to multiply this whole term by minus b. That's when you get the value of b. So value of b is going to be minus phi, which you will plug it in here in the general equation, by which you will get minus phi x square. Now let's see to how to find the value of c. Since there is nothing here down, I said to you as the value of a is going to be 1. So in place of ax square, if you place 1, it will become 1x square, which is x square. So it's going to become x square minus 5x, and now we have to find the value of c, which you will be getting from alpha into beta. That is 1 into 4 is going to c by a. So c value is going to come 4. So we are going to plug it in the value of c here in the general equation. Will get us x square minus 5x plus 4. So with this, guys, you can take a screenshot. I'll move aside. So with this, guys, the exercise 2.2 of your NCERT textbook is over. Now next topic will be going to the division of polynomials, and then there's one exercise based upon division of polynomials, and then we are going to wind up the chapter. Before going to the next topic and the next lecture, I want to tell you people one thing is that by now, by practicing this exercise with me, you would have fairly understood the concept very well, I hope, and I also hope that you would have memorized these formulas, the relations. Now to make sure that you always remember this, keep practicing it time by time, guys. Keep revising it, or after some days when you feel like you have forgotten some concepts, you can always come back and watch my videos to remind yourself, or else you can take the help of your NCERT textbook. Since I have taught you this much, when you read your NCERT textbook now, I believe that you are going to feel it quite easy, guys. And also, not just stop with NCERT, guys. Go and refer few reference books like R.D. Sharma or R.S. Agarwal. Practice few questions from them as well, so that you always remember it well, and so that you get a good practice of maths, guys. Maths is all about practice, so make sure that you practice maximum question possible. And this topic, guys, and this topic and this exercise is going to be very important from your examination point of view as well, guys. I am pretty sure a question from at least of any of this type, either given the question and given the equation, and they would tell you to find the zeros and verify the relation, or else they would give the zeros as we have in like second question, and they would tell you to get the equation of the polynomial. So make sure that you become thorough in this concept, guys. So let's meet in the next lecture. Bye.